This is a presentation on the design, fabrication, and performance evaluation of a portable and cost-effective 3-axis CNC drilling machine suitable for small and medium scale manufacturing industry. I'm Engineer Peter Linepopo, a lecturer in the Mechanical Engineering Department of Federal University of Operational Resources, Efron, Nigeria. I hold the BNG in Metallurgical Materials Engineering from the Nnamdi Azikiwe University of Anambra State, Nigeria. MNG in Physical Metallurgy from the same institution, and currently I'm pursuing a PhD in my home school, Federal University of Operational Resources, Efron, Nigeria, in the Mechanical Engineering Department. My outline, I will look at the introduction, aims and objectives, methodology, results and discussion, and then run to the conclusion and make some recommendations. Firstly, introduction. Drilling machines. Drilling machines are very important machines because we need them for most manufacturing operations, so bore holes or make holes in materials. Now, CNC machine, which stands for computer numeric control machines. They are finding applications in drills, mills, and lathes because they are very accurate. They take codes from a computer and they use it to control motors and other positioning parts to help control spindle to bore holes or do other operations on the workpiece. However, the CNC drilling machine have some problems. One of it is that they are usually large, so it's difficult to move about. They are not portable, that's what I mean. Secondly, another problem with the CNC machines are that they are very expensive, so only very large industries can purchase them. So the problem here is that small and large scale industries find it difficult to purchase CNC drilling machines because of the high cost. So the aim of this project is to design and fabricate a portable drilling machine which uses the GRBL shield expansion board and Arduino microcontroller board suitable for use in small and medium scale manufacturing industries. Some of the objectives are as we'll create the CNC parts using a CAD design. Then we use that to fabricate and assemble the prototype. Then we'll write G codes and send to the machines, and then we'll test to see if the machine will follow the code sent to it. So this is the basic workflow chart that we're going to be using to create our CNC machine. This is the CAD, the exploded view for the drilling machine. This is a detailed drawing for the X-axis trail. This is a CAD drawing for the Y-axis. This is a CAD drawing for the Z-axis, since it's a 3-axis drilling machine. This is the overall dimensions of the CNC machine. This is the side view of the machine. So after we got our machine, the prototype, we had to test to see if our code was rigidly followed. So we used two types of soft tool and hardware to test our machine. We used two types of drill. We use high-speed steel drill, which is HSS, and the carbide twist drill for different feed rates and different depths of cut. We use the vernier caliper to measure to see if we got the exact measurement we were expecting. So this table 1 and table 2 shows the We measured responses for softwood and hardwood respectively. So this is a graph of the machining time versus depth of cut for softwood and hardwood. We saw that for the carbide drill had higher machining time than the high-speed steel. The results are similar for both softwood and hardwood. The same trend was observed. However, the machining time for hardwood was higher. For carbide, it was about 20 for when we observed for a depth of cut of 1, and it ranged to about 25 for depth of cut of 5 mm. While for softwood it was between 8 and 14 for the same range of depth of cut. So this is a graph for machining time versus feed rate for softwood and hardwood. It was observed that the machining time reduced as our feed rates increased. So the same trend also for both woods. We saw that both reduced as the feed rates increased. So we can conclude that the drilling machine was successfully designed and fabricated, and the machine responded positively to the G-code. We saw that every message we sent to the machine was interpreted and it was followed rigidly, and that the machine can be used to drill holes both in soft and hardwood. And we recommend that this machine should be used or can be used for small and medium scale industry. The machine is also versatile in the sense that you can change the drills, depends on the size you want to achieve. You can have different designs of different sizes of drill, different types of drill for this machine. So yes, the machine is recommended for use as a portable machine for small and medium scale industries. Thank you.